All right, now let's talk about different kinds of economic data sets. And again, guys, the reason that I'm using economic because the textbook says economic, but you can apply it to anything, right? To any major, to any field, medicine, anything. Okay, so in general, we have four types of data sets. If you have taken statistics, you're already familiar with them, but let me quickly refresh your memory. So we have cross-section, time series, panel, or we could sometimes call it longitudinal, and then pooled cross-section. So the best way for me to explain it to you is basically give you a very simple example, and hopefully you'll never forget that example. Okay, so let's see. We are going to start with cross-section, right? A cross-sectional data. Imagine I'm talking about, let's say I have 20 students in this class, right? Again, I'm just making up some numbers. And I want to collect information on your GPAs. Okay, so let's say I have GPA, and here, let's do it this way, and then I have 20 students from number 1, 2, 3 to number 20. Okay, I can report the GPA, and imagine this is GPA for, I don't know, let me report it annually for simplicity, 2020 so far. Okay, so again, student number 1, GPA is 4, number 2, 3.6, number 3, 3.8, and the last one, GPA is, I don't know, 2. No, we don't have 2, it's 3.9, let's say. Okay. So we call this data cross-sectional data, right? So we have individuals and we're collecting information for all these individuals at one time, one point in a time. So let me use another color. So this is cross-sectional data, right? So cross-sectional data is multiple individual, multiple people, multiple countries, multiple, again, you name it, objects at one time. Okay, so let's say this is GPA at 2020. So this is our cross-sectional data, number 1. Now, let me try to fill up this. Let's say for each of these students, I can collect GPAs for 2019, 2018, and etc. Let me keep it simple and go to here. That's okay. So student number 1, we have 3 numbers. So GPA in 2020 it's 4. Last semester was a little less, 3.9, and the year before it was 3.8. So this student is improving over time, right? Then for second student, let's say maybe last year it was better, the year before it was even better. So this student is completely the other way around. It's his or her GPA is depreciating over time, and etc. For the last one, this guy's persistence 3.9, 3.9, 3.9. Okay, so look at that. The second type of the data, it's time series. Time series is when you're looking at the observations for one individual, one country over time. One firm, again, you name it. So here in this example, we have one individual, which is one student over time. So let me use another color. Let me use green. So this is going to be our time series data. So 2 time series data. Let's go back to slides. So we're done with cross-section. So cross-section is multiple people at one time. Time series is one people over multiple time, one person over multiple periods. And third one, as you can guess, it's a combination of the two, right? So it's panel data. So if I combine the two, so basically multiple people over multiple times. So let me use black. This is going to be our panel. Again, we're going to go over very detail of cross-section, time series, and panel in the following slides, but I just want you to remember this as a easy example of how we compare them. And finally, the last one is pooled cross-section. So what is pooled cross-section? As you can guess, it has something to do with multiple cross-sections. So let's say we have two cross-sections, three cross-sections, and we're pooling them together. So it's not panel, it's not cross-sectional, it's not time series, it's multiple cross-sections, and we're combining them together. So let's look at an example. And let me use, let's see what other colors I have. Well, let me use one of these fancier ones. Okay, so let's say again, we are pulling some cross sections, right? Let's say in 2020, I have data only for the first 10 students. Something like that. Okay. For 2019, I have data for these students. This is not the best color. I hope that I'm not confusing you guys. And in 2018, I only have information maybe for these guys and these guys. It doesn't need to be, for instance, continuous, right? It can be, I have the information, again, for some reason, we don't know why, but for some reason, I only have these things, right? This information, this information, this information, this information. So do you agree that this one is cross-section, this is cross-section, this is cross-section, this is cross-section? We're pooling these cross-sections together, and we call it pooled cross-section. Okay, so again, we are pooling cross-section. And in the following slides, you're going to see that when and why exactly we need to pool, what kind of data sets we're going to work with in these pool cross-sections. So again, as a quick summary, cross-section, looking at multiple people at one specific time series, one person over time, panel, multiple people over multiple periods, and pool cross-section, as it's self-explanatory, pooling of cross-sections. So that's the way that I think you should always remember for distinguishing time series, cross-section, and etc. Now let's go back to slides and look at more formal definitions for these things. Let me use maybe red again. All right, so starting with cross-sectional data sets. So cross-section is sample of individuals, households, firms, cities, states, countries, again, anything, any other unit of interest at a given point in time or in a given period, right? So it's not exactly you don't collect GPA of 2020 at exact one time, 1 hour, 1 second. No, it can be a given period of time. You say, okay, 2020, 2019, and you know that you are finding those numbers over time. So this is an official definition of cross-sectional data set. And let's look at some properties. Cross-sectional observations are more or less independent. So if you go back to our example, again, the chances that the GPA of first student is the same as the second, well, has something to do with the GPA of second student and third student is very, very low, right? So this is a property of cross-sectional data. Okay. Again, there might be a relationship between the two or three or multiple of them, but this should not be systematic. Okay. For example, pure random sampling from a population. We're going to talk about it in our, and I'm going to specifically talk about this one in our detailed class. But basically, the idea is that when you're random sampling from a population, it's basically using with cross-sectional data. So let's say I have a population of 100 students, and then each time I'm picking 20 of them, 20, 20, 20. And if I make sure that this 20 out of 100 is completely is done randomly, then the odds that they are independent, it's high, right? So this is a one property of cross-sectional data. A key feature, I want you to remember this one. Ordering of the data does not matter. This is really, really important. go back to our example. Do you think that if I report the cross-sectional data like this, or do it reported like, so what is the GPA for the third students, then 10th students, then 20th students, then the first students? It really doesn't matter how do I stack up this column, going from 1 to 20 or doing something like this. So ordering doesn't matter. So this is a key property of cross-sectional data. All right. Let's look at some examples from the textbook. So this is a cross-sectional data sets on wages and other characteristics. So this is observation number. And basically, it's just a counter, observation number 1, 2, 3, like the student number, right? So for each observation, we're collecting what? We are collecting wage, we are collecting education, experience, gender, and marital status, right? Look at that, and it's done all in 1 year. So this is a cross-sectional data because we are collecting information on one or many variables, but at one specific time, right? So this is at one time for each person, we are collecting this information: wage, education, experience, gender, and marital status. So let's read one of them together. So let's read observation number 5. It says that the wage is $5.3 per hour. Education is 12 years. He or she has, well, actually, we know that if it is he or she, female is 0, so it's a he. He has experience of 7 years. And again, we know it's he because female is 1. We know that anything else is male, so 0 is male. And then marital status, he's married. Okay, so this is how you read one observation. So this is an example of cross-sectional data. And again, and by the way, this type of data set, cross-sectional, is what we're going to cover in this course. In this course, we are going to focus only on cross-sectional data set, okay? But you should know what is time series, what is panel, what is a pooled cross-section. And in more advanced econometrics course, you will work with those things. And again, if I'll talk a lot in more details that in what courses you're working with, what type of data sets. But for now, just remember in this course, this is the only type of data set that we're going to work with. Okay. Now let's go to the second type of data set, time series. Observations of a or several variables over time. So we can record one variable or several variables over time, but for one person, for one individual. Okay, so that's time series. So for instance, I can say for student number 1, I can collect GPA, I can collect height, I can collect the weight, I can collect study hours, and you name it. But as long as I'm collecting all this information for 1% over time, so GPA over time, so if I want to plot it, so it says that, let's say this is a GPA, it's going to increase. Height, most probably is constant at your age. Weight, maybe you're increasing or decreasing weight. Does that make sense? I don't know, maybe this is your weight. And then study hours, hopefully over time, you know that you need to study more, things like that. Okay, so this is time series. All of these plots are for one individual. Okay, for example, stock prices, consumer price index, GDP, gross domestic product, automobile sales. And this is what you see all over the news. If you watch CNBC, for example, you're going to look at the stock, Apple stock price. So going up and down, up and down. So this is an example of time series. So what is the price of one company over time? Okay. And I know some of you guys are super interested in this one, in time series, but remember, this course is only focused on cross-section. So it's both good and bad. The good news is that when you learn the cross-section, then transition to time series is literally a piece of cake. The bad news is that you don't get to work with stock prices or things like this in this course. Okay, but again, look at the bright side when you learn this, because this course is going to be used as a building block for your more advanced courses in econometrics, machine learning, deep learning, and you name it. This is a very, very important course set. Okay. What's the other properties of time series? Time series observations are typically serially correlated. Remember, if I go back to the previous slide, I want you to, let me use another color to highlight it. Let's use green. Look at that. The signature of cross-sectional data is that they're more or less independent, but look at the time series. Time series observations are typically, not always, but typically serially correlated. What does serially correlated mean? It means that they're correlated over time. So let me give you an example. So this is a valid chart for time series, right? So you know that Apple's stock cannot be like this. So for instance, today is 500, tomorrow it's 200, then the day after tomorrow is, I don't know, 1000. It's not like that, okay? Well, even if it is like that, we know that over time, they are correlated. So you see there's a trend here. So what is the price today is not independent of the price yesterday. So so the price comes from the price of yesterday plus minus something, right? So they're serially correlated. So this is a signature of time series. Data frequency, it can be daily, weekly, monthly, quarterly, annually, and nowadays hourly, by minutes, by second, millisecond, high frequency trading, things like that. It can be anything. Typical feature of time series, trend and seasonality. Okay, again, we're not going to open up these things here in this class, but what is trend? So this green line is trend. So for instance, if this is a Apple stock, then the trend is upward. If you look at some other stock, the trend is going to be upward or downward. Or some stocks, there's no trend. What is seasonality? Seasonality is something that happens over specific periods in time. So for instance, in the stock market, we have January effect. So what is January effect? Basically, we know that in December, companies needs to report tax, and then so usually portfolio managers are going to say, okay, they're going to close their losing positions to realize losses for the year, and at the beginning of the next year, right at January, they're going to purchase all those stocks that they have liquidated. So we see that in December it goes down, in January it goes up again. So this is called seasonality. Or again, think of a housing market. We know that in the summer, usually the price of a house goes up because there is more supply and demand, because of the schools are open and things like this. And each year, so let me actually, for fun, let's plot the housing. Let's say these are year 1, year 2, year 3, and I know that in summer it goes up, and then in summer it goes up, and then in summer it goes up, right? So there is a general trend. The general trend is upward. The general trend is upward, but you see there's a seasonality. This is summer, 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 the price is higher. So this is trend versus seasonality. Again, I'll stop here because we're not going to talk about these terms in this course. A key feature of the time series is that the ordering of the data does matter. So remember, in cross-sectional, the ordering didn't matter, but here the ordering does matter. So it means that I have to plot these things based on time, and time starts from, let's say, period 1, 2, 3. It comes at a sequence, so I cannot change that sequence. So the ordering does matter. All right, so let's look at an example of time series from the textbook. We're looking at minimum wage and related variables. So observation number 1 through 37, 38. Again, if you guys are interested in the narration of these examples, just feel free to read the textbook, but the textbook is not mandatory for this course. And you should be fine if you just follow with me over the slides or come to the class for detailed class sessions. But if you're more interested and, I don't know, curious, you can go ahead and read the textbook. Okay, so what do we have? Look at that. In time series, there must be a variable called time. So year, minutes, hours, days, month, and etc. Right? So here we have year, 1950, 1951, 52, etc. Then for each year, we are recording some numbers, right? So we have, this is average minimum wage. This is average coverage rate. This is, for example, unemployment rate, and this is GDP, gross national product. Actually, it's GNP, gross national product. And this, remember, what was the signature of time series? It's for one individual, one country, one person. What is the country here? Puerto Rico. So we're reporting these numbers for one country. If it was multiple countries over multiple time, it was panel. But now it's one country over multiple period, so it's time series. And basically, it's showing you some patterns that so you think that there's a relationship between minimum wage and unemployment. And by the way, for this one, there's a theory. But again, as I said, we don't care about theory. We just trust the data and see what the data suggests. Theory may be good to give you to establish the relationship, but guys, nowadays when we have thousands, millions of records of data, I personally believe that we should trust data more, because there is no single theory out there. You take it from me. Well, it's not from me. It's a very famous quote. There is no single true theory out there, because look at the I don't know, history of economics. It comes, there are lots of newer theories that are contradicting the previous ones, because things has changed and we have to come up with newer models, right? And this is how we push the edge of the knowledge in any field. Okay, so that was time series. Then the next one is panel or longitudinal data, which is a combination. So, but I want you to focus on these key terms. The same cross sections, the same cross-sectional units are followed over time. This is key. Same cross-sectional units. Let's go back to our example. I have 20 students here. I am looking at the cross-sectional units, cross-section 1, cross-section 2, cross-section 3. They're all the same to all 20 of them. Look at the black one, all 20 of them over time. All 20 students over time. So this is panel. If this is not the same, so for instance, the first one, where is the first one is this cross section, the second one is this cross section, the third one is this one, the fourth one is this one. If you're not talking about the same cross sectional units, it's going to be pooled cross section. But if you're talking about the same cross section units, it's going to be panel. All right. Panel data have a cross-sectional and time series dimension, so it's obvious because we go both over multiple people and over multiple time. And ordering in the cross-sectional doesn't matter, but in time series matters, right? So this is nothing new. It's a combination of time series and cross-section. We know that ordering in time series matters, in cross-section doesn't matter. Let's look at an example. Okay, this is a 2-year panel data on city crime statistics. So there's going to be an in-class exercise. I want you to, after watching this video, you're expected to submit your answer. It's going to show up as a quiz on Canvas. And don't worry about the grades, because I use it as your attendance, and I want to make sure that you have watched the videos. So just you will get the point based on completion. So if you complete the quiz, you will get the full point. But try to do it at home and make sure that, I don't know, try your best and see if you can answer the questions correctly. So I will, even on the exam, I will give you something like this, and I expect you to come up with, is it a cross section? Is it time series? Is it panel? At first, it seems very easy, but sometimes it's a little challenging and confusing. But again, we're going to talk about more examples in the class. So let's look at this one. This is panel. Okay, how do I know that this is a panel? So first of all, there's a clear sign of time. We have year. And secondly, look at that. We have city, but city 1 is, we have 2 of these city 1s, 2 of city 2, etc. Right? It seems that for each city, I have 2 times, 1986, 1990, 1986, 1990. So it seems that I'm tracking the records for multiple cities, multiple objects over multiple periods, which is here happens to be 2, right? So this is panel, right? I'm going to say that city 1, city 2, city 3, and up to city 150. And then you're looking at the murder rates, population, unemployment, and number of police force. So you can tell a lot of stories by just staring at the data, but we're going to use econometrics to help us to narrate those stories, right? So for instance, if I look at this one, I don't know, it seems to me that if I go from 1986 to 1990 at each city, Well, it seems that the number of murders for the city number one increased, the city number two decreased. Maybe, again, you can say something like this, but you want to see if there is a relationship between number of murders and number of police. So for city number one, I'm focusing on this one. Well, the number of police is increasing from 1986 to 1990, and the number of murders surprisingly has also increased. So again, this can be some observation. But we're going to use econometrics to solidify these observations, right? To tell us, to guide us, to tell us, to quantify this relationship for us. But this is not a place, well, actually, you're not going to learn panel in this course, but we're going to do same thing for cross-sectional data. And then after that, you can extend it to panels as well. But in this course, we're going to focus on cross-sectional data. And finally, let's talk about pooled cross-section. So two or more cross-sections are combined in one data set. We already talked about it. Cross-sections are drawn independently of each other. Again, so basically it says that these things are independent from each other. We draw them independently. Pooled cross-sections often used to evaluate policy changes. And this is where I promised you that I will give you a use case where we use pooled cross-sections. So let's look at an example. Let's say we know that, well, it's a fact, the property tax in 1994 was dropped suddenly. And we want to see what was the effect of that drop of the property tax. So we have to collect information before 1994 and after 1994, and then see how the relationship between variables changed. So that's why, one example that why we can use pooled cross-section. Again, it has huge application in policy changes, policy application. So we evaluate the effect of changing property tax on house prices. We ran the random sample of house prices for the year 1993, and a new random sample of house price for year 1995, right? Again, the policy was enacted in 1994, so let's look at the data in 1993 and 1995. And we compared it before, after that policy date, right? So let's look at the data. All right. So pooled cross-section, and imagine I give you this, and you're supposed to figure out what is it? Is it panel? Is it pooled cross-section? Is it time series? It's easy to say that it's not cross-section, but because you're using time. Okay, so cross-section is out. But, and also look at that. You have observation number 1 to observation number 250. And we have 1993, 1993, and we have 1995, right? Okay, so here is a tricky one. You might want to say that, okay, this is panel because I am following multiple individuals. So here is houses, multiple houses over multiple years, 1993 and 1995. You are kind of right. It is panel, but look at that. Remember, panel, this is a little tricky. I want you to pay attention. Follows same cross-sectional units over time. For pool, they are not necessarily the same. Look at this one. Oops. We have 250 observations. So for year 1993, we have 250. But look at that. For year 1995, we don't have 250. We have 270, right? Because it goes to 520. So 250 here plus 270 is 520. So here we have 250 houses. Here we have 270. So definitely they're not the same. Even if 250 of them are the same, 20 of them are not the same. So because we are tracking different cross sections over multiple periods, this is pooled cross section. It's not panel. Okay, guys. So let me stop here. And we are going to make our last video for the class number 2 in a separate one. But the second video, we covered time series, cross-section, panel, pooled cross-section. In this course, we're going to focus only on cross-section. So it's okay that if you cannot, if you were a little overwhelmed with what is panel, what is full cross-section, it's no big deal. We're not going to use them for this course, but however, I may ask you one question on the exam to make sure that you understand the difference between these things, even though we're not going to use, we're not going to, for instance, do any kind of coding for panel or full cross-section. Okay, so let's stop this video here, and then I'll see you in the next one.